I'd like to talk a little bit about the condensate removal and trap requirements for most Category 4 type furnace applications. So specifically, the removal of that latent heat during the combustion process in that heat exchanger causes a very acidic condensate to be formed. And that acid, can be anywhere from a 5 to, could be lower than that, down to even as low as 2. I've seen it where it'll eat away through copper pipes, it'll eat away through aluminum, it'll eat away just about anything that is not really set up as stainless steel. So you really have to be careful with that and make sure that you're using appropriate materials for that to properly get rid of those condensate liquids. And in some of the cases, if you're below a 5, they may even require you to utilize a neutralizer so that you don't create damage to any type, especially any type of steel piping, anything like that, and most notably in older buildings. Buildings that are using PVC drainage systems, you shouldn't have to worry about those. Some of the homes that were built in the 70s, 60s, 70s, they had actually did with, as far as the drainage of your sewer pipes and those types of things within your building, those were actually done in a lot of cases in copper. And they, if it wasn't done in actual cast, some of the homes were done in actual copper. And those are just something you have to be aware of. If you see that, you really cannot run a condensate furnace in there without neutralizing those liquids. So anyways, that's a little bit on some of that. So all right, so due to that need to remove them, there also is some of the requirements of that, and the fact that most of the manufacturers will supply you a trap, but that is kind of specific to their furnace, which is awesome. It minimizes our requirement to build that, and but you have to essentially make sure that the trap keeps these things in mind. There are some older appliances where you had to build the trap and you had to make sure that it was working right. So first thing I wanted to hit up on this is the furnace trap is a requirement to allow the furnace to actually drain. And what you don't want to have is, you don't want to have it where the inducer motor, when it does kick in, when this particular motor kicks in, when this motor kicks in, this inducer motor kicks in, what you don't want to have happen is, you don't want to have it where that particular motor creates a suction or a negative pressure, which would, without a trap, would allow you to take those gases, or the air that would be in that line, or without a trap, and it'll draw it from here as opposed to from here. So that's the issue that you have to be really careful with. So they talk about specifically, where that water that is in that trap is designed to be heavier, and it's got to have enough of a differential in there that would force those products of combustion to be pulled through the heat exchanger and not through the trap. And so as a general rule, the recommendation generally in our field is somewhere between 2 and 4 inches will handle most of our trap applications in a system. Again, you really have to watch it to make sure that there is no issue with that. If the manufacturer supplies you one, chances are it'll easily meet those requirements. So if you do have a trap that's already installed on the unit, try to avoid a second trap. So the second trap that we're referring to sometimes can be very unintentional. And if, where you might have an application where there's an additional loops or traps in here that are creating problems with not allowing that product or those products of combustion to vent out. And this is especially true if there is not an air gap. So this air gap is very important in any of your applications. So you really want to make sure that you are creating that separation in there. So very significant on that. So the whole goal and the whole bottom line of this is we want to get all the gases to be totally controlled and brought through the system, brought all the way into the collector box, be allowed to be drained out of the inducer assembly into the trap, and then on out. And essentially this big air gap right here is a really key component of that. Additionally, we want to make sure that the vent gas is coming out of the discharge pipe that is actually going to be pitched appropriately and allowed to drain in an appropriate spot. In some of the situations, they may even require you to have some sort of an additional T that would allow any excess condensate to drain out of there. So that's typical. And again, I'll reiterate this because it is somewhat important. Most people have figured this out because our condensing applications have been out, really since the 80s. And just make sure whatever that line happens to be, that it's sufficiently sized, that it doesn't get clogged up, that it's maybe handled in an appropriate manner. If it's allowed to freeze, there's going to be problems. If you get that acidic condensate going into let's say a cast iron type of a drain system, it's going to create a problem. So anyways, just thought I would mention those related to condensate.